Welcome. We're going to do another example of finding and classifying critical point for function of two variables. This time I don't have a polynomial, so in particular I'm going to get a nonlinear system. The function is xy plus 1 over x plus 1 over y. Differentiation will be easier if I write the fractions in terms of negative exponents. So I'm going to write this function as xy plus x to the negative 1 plus y to the negative 1. I'm going to next find the first order partial derivatives, set them equal to 0 to give me the equations for the critical points. If I differentiate with respect to x, in the first term I have x times y, derivative with respect to x is 1 times y. In the second term I have x power negative 1, its derivative by the power rule is negative 1 x power negative 1 minus 1, or negative x power negative 2. In the third term I have only y, treat y as a constant when I differentiate with respect to x, so its derivative will be 0. The partial derivative with respect to x is y minus x power negative 2. Similarly, or by symmetry, because if you switch x and y, function doesn't change. So I can just switch x and y in this to get the partial derivative with respect to y. That gives me x minus y power negative 2. I set that equal to 0 as well. It's a nonlinear system. We will solve this by substitution. I'm going to solve for y from the first equation. We just take the term negative x power negative 2 to the right hand side. So y is x to the power negative 2. I'm going to plug this in the second equation. And even if I have negative exponents, when I have repeated exponents, I just multiply them. So x power negative 2 to the power negative 2 is x to the power negative 2 times negative 2, or x power 4. So the equation is x minus x power 4 equals 0. I'm going to solve this for x. I have a polynomial equation, so I'll try to solve by factoring. I can factor an x out of the two terms. I get x times 1 minus x cubed equals 0. X equals 0 is not in the domain of g because I have this term 1 over x, so x cannot be 0, which means x cubed is 1, so x is equal to 1. And y is 1 to the power negative 2 because y equals x power negative 2, so y is also equal to 1. So again we have only one critical point, namely 1 comma 1, and we'll use the second derivative test to decide what type it is. Gxx is the derivative of gx with respect to x. So I have to differentiate y minus 1 x power negative 2 with respect to x. The first term has only y in it. When I differentiate with respect to x, I treat y as if it's a constant, which means the derivative of y with respect to x is 0. The second term I have negative x power negative 2. I can just use the power rule. I get negative times negative 2 times x power negative 3, or just 2x power negative 3. Similarly, gyy will be 0 minus 1 times negative 2 times y power negative 3, or 2y power negative 3. Gxy is the derivative of gx with respect to y, so I have to differentiate y minus x power negative 2 with respect to y. The first term I have just y, its derivative with respect to y is 1. The second term I have only x. I treat x as if it's a constant when I'm doing partial derivative with respect to y. So the derivative of negative x power negative 2 with respect to y is 0. So gxy is just 1. So the discriminant is 2x power negative 3 times 2y power negative 3 minus 1 squared, or 4x power negative 3 y power negative 3 minus 1. If I plug in the critical points coordinates, 1 for x and 1 for y, I get 4 minus 1, that's 3, that's positive. So 1, 1 is a relative extremum. To figure out it's a relative max or relative min, I need to plug in the coordinates of the critical point into gxx. Gxx is 2x power negative 3. If x is 1, it comes out to be 2. That's also positive, which means that 1, 1 is a relative minimum.